You've probably seen some printers with beautiful flowing part fan ducts that look like these, or maybe even better than these, but have you ever tried to create one yourself? It looks a bit tricky, but I'd like to show you how easy it really is to do, and we're going to print it, we're going to test it, and we're going to see how it does compared to my new best performing duct called the Medusa. So, stick around. Lofting shapes can create some amazing looking parts with nice, smooth, and durable transitions from one shape into a completely different one. And it's pretty simple to do when the shapes are on parallel planes, or at least they are not far off of parallel. But how about trying to loft shapes which are not even anywhere close to each other? You can create a whole bunch of different planes and sketches at different angles and then loft each one to the next. That method is extremely time consuming and does not give very good results at all. There is a far easier way to create shapes that are as simple as this or as complex as this without spending too much time at all. We're making real parts today, so I have a 3D printer hot end modeled already with 3 mounting points here. In this area up near the top is where the air is going to be coming from the fan. So we need to get that air close to the nozzle and fairly precisely placed as well. And I'm going to have this model available in a link down below if you'd like to try this out yourself. So we have a starting shape up at the top, and that one is going to stay as it is. But near the nozzle, we need to have the ending shape. And in this case, I'd like it to be on a slight angle off of vertical to help direct the air towards the bottom of the nozzle. So I'm going to create a construction plane at an angle, something like 100 degrees works pretty well. And then we can also offset for a little bit of clearance as well. And now we can create a sketch, and it's going to be a good idea to project something at least to be able to assign a constraint, so it becomes easier to change this if we want to later on. So we can project maybe the tip of the nozzle, and then just to make it fun, we're going to be using a long, thin rectangle to start. We're going to give it some dimensions, and in this case, I'd like to position it off slightly to one side of the nozzle. Now I also want 2 of these instead of just one, so we could create another sketch in the exact same way for the second side, but I want the other side to be rotated 180 degrees rather than to be mirrored. So what I'll do is make a thin extrusion as a reference, and then I can pattern it around the center of the nozzle. And I'm doing this because I'd like to see if we can test the vortex concept for cooling, and having symmetrical sides will not accomplish that. And now we're moving on to the fun part. So there are a few different ways to start with this. You can draw a 2D sketch and then move the points afterward to wherever you need them. But I found that starting in 3D works really well, and it's also super quick. So we can create a sketch and make sure that we have 3D sketch turned on. And then we can select Fit Point Spline and then pick our starting point as the center of that air coming from the fan. Then as we're sketching, we can also select which planes we want to move along for our next point. These points can always be changed later on. We just need to get something that's pretty close. So we can select this plane first, and then the next point will be moved out, and then we can change the plane and then move along in this direction now. Now you might be tempted to add a whole bunch of points to get the exact shape that you're looking for, but I have found that it is better if you only add the bare minimum. So I just add 1 point along the way. Now, if you have added a bunch of points, you can also just select those and delete them afterward. It's going to give you a much more flowing shape, and it's also going to be a lot easier to work with as well. And now for the end point, I want it to be centered on the mouth, but it is snapping to the center of the arc instead. So I'm going to pick that end point, remove the constraint, and then select Move from point to point, and then position it correctly. When it comes to 3D sketches, I normally don't constrain them, but if you'd like to, you can. So we have that single point to constrain along the path, and we need to set dimensions to each of the planes since it can be moved in any direction. So we can dimension it to the X, Y, and Z origin planes, and now we can change one at a time and move that point exactly where we need it to be. For the purpose of this video, I'm not going to be using it here since it's already really easy to move it around in any direction. So we have this shape, but it is not really right. What we need to do is have it begin as close to perpendicular to the starting object as possible, and the same goes for the end. So we can go to that sketch, and in the case of the start point, viewing from the top is not going to be helpful, but viewing from the side and also from the back is going to be. And we can select the line. These handles will appear, and they're going to give us the ability to change the size of the curve and also the angle, and we can adjust them to whatever we need from the back and then also from the side. And then we can do the same for the end point of the line. And here we can make the change from the top and from the front view as well. And now we can select the loft command, and we need to pick our starting object or starting shape, and we need to pick our ending shape as well. And then we can select guide along centerline. Now with that, we can see the shape a lot better, and those handles can also be refined a bit more. Now we can do the same 3D sketching for the other side using the original sketch as well. And on this side, it's going to be a little bit different, of course, than the other side because of the position of that little mouth in relation to the nozzle. With both of the sides finished, we can combine them, and then since we have fairly complicated shapes, I'm going to be using them to attach the mounts by using the subtraction method. I can then hollow the ducts out and use a 0.7 millimeter wall thickness, and that's what I found works pretty well. Now we can combine the mounts to the ducts and refine all of this with some fillets as well. These are going to be pretty close to the nozzle and to the heater and possibly close to the build plate, so it's best to print these from something that can take the heat, like polycarbonate or maybe ABS or high temperature PET. I'm also using ABS glass fiber 25 from Cheedy for this particular part. I have very thin layer lines as well to make sure that I end up with something that looks good on the overhangs. In the previous video, we had the dual version, but with the air streams directly opposing each other. This version has that vortex style of setup, which may be able to cool a little bit quicker because the warmed air can more easily move beyond the nozzle. This also has a smaller area in the middle where the streams were meeting at the nozzle, which was creating a lot of air moving down and a lot of turbulence as well. This is the double from the previous testing video, and this was the overhang result. And now if we compare them, the 15-degree overhangs are very similar. There may be a slight improvement on one of the 10-degree extrusions, but it's not really enough of a difference, to be honest. I have another version that I've been working on called the Medusa, and it has 6 mouths which are each offset slightly to one side of the nozzle, and this one seems to provide an overall better result. So this Medusa was created using the exact same methods as I just showed, except for in this case I broke it down into 2 operations. First was to create this kind of a manifold setup, and I transitioned from the circular shape to an oval shape for each of these, and then from that oval shape to this more rectangular mouth shape. Now this one here was a little bit more complicated. Each of these ducts is quite small, and in order to get these strong enough, what I did was I had them come past each other and just barely touch, so they are connected and much stronger that way. There's still a lot of room for improvement here, so I have some new equipment on the way so we can better visualize what is happening, and that will be shown off in the next video. So if you aren't already subscribed, make sure that you do that and hit that notification as well so you know when it is released. Also, in that next video, I'm going to be talking about the challenge that I am issuing to each of you, and there will be real rewards as well. And the goal here is to find the absolute best method of cooling and then to be able to adapt it to fit on any 3D printer. Thank you to each of my patrons for supporting this channel and making these videos possible. Of course, if you want to help support this channel as well, there will be a link down there below. Take care, I hope you enjoyed the video, and we will see you on the next one.